In this video, we are discussing carbonyl compounds. Carbonyl compound means what? Compounds containing carbonyl group. Compound containing carbon-oxygen double bonds are carbonyl compounds. So, when you look at the structure of aldehyde and ketones, this carbonyl group is present. You can observe this carbonyl group. So, because of this, aldehydes and ketones are carbonyl compound. Obviously, under the heading of carbonyl compounds, we are going to discuss aldehydes and ketones. Aldehydes and ketones, if you look at their structures, one valency of carbonyl carbon. This carbon is carbonyl carbon. That word may come again and again. So you remember, first of all, this carbon is a carbonyl carbon. And if the valency, one valency of the carbonyl carbon is having hydrogen, then that compound is called aldehyde. And another is R, that may be a alkyl group or any aromatic ring. So here, if hydrogen is not attached to the carbonyl carbon and both alkyl groups or aryl groups are attached to the carbonyl carbon, then this is called ketone. So we are going to discuss aldehyde and ketone. Aldehydes are again maybe aliphatic aldehydes or aromatic aldehyde, depending on whether aromatic ring is attached to this carbonyl carbon or not. If aromatic ring is not there, that you can call it as aliphatic aldehyde. And if aromatic ring is attached to the carbonyl carbon, then it becomes aromatic aldehyde. So similarly, ketones are also aliphatic ketones and aromatic ketones that we will discuss in more detail in next videos. First of all, we are going to discuss the nomenclature of aldehydes. This is actually, for the nomenclature of aldehydes, we have to select the longest chain of carbon. In that carbon chain, you cannot skip carbonyl carbon. Again, that word is coming, carbonyl carbon. So this carbonyl carbon you have to consider along with the longest chain of carbon while providing name to the aldehyde. Then second rule says the carbonyl carbon is always 1. So you have to start numbering from this carbonyl carbon. And then third, you find out the name of substituent along with their locand numbers. Locand number means at which carbon that substituent is present. Fourth point, you have to find the name of the parent alkane. You simply count the number of carbons present in the compound, and from that number you can find out the name of the alkane, that is called parent alkane. So from this rules we can provide IUPAC name to any aldehyde. Let us take few examples to find out the IUPAC name of the aldehyde. So I am writing here CH3, CH2, CH2, C double bond O and H. There is no substituent, but as per these rules, you have to start numbering from here 2, 3 and 4. So if numbering, if branches or any substituent is present, then only numbering is required. Otherwise, you need not to give the number. Here, I have replaced one hydrogen with the chlorine. So there is a substituent. Now the numbering is required, and numbering is started always with carbonyl carbon. So 1, 2, 3. As per this rule, now you can check here our second rule. The carbonyl carbon is getting carbon number 1. Now the name of the substituent you must find out. So substituent, I will find here substituent. Just one substituent is present at carbon number 3, and that is called 3-chloro. So this substituent is 3-chloro. Then parent alkane, that is again our fourth rule. Parent alkane means simply you count number of carbon present in the chain. So there are 4 carbons, so parent alkane is a butane. Again, after this, you have to replace this E with Al. So that becomes butanol. So this is butanol. So this is butanol. So what is its IUPAC name? While writing IUPAC name of any aldehyde, you have to arrange all substituents, in alphabetical order and prefix to this parent name. So what is it? Substituent plus parent alkane. So substituents means alphabetically arranged substituent. So there is just one substituent, that is chloro. You need not to arrange, that is not required. So what is its name? The name of this compound is 3-chlorobutanol. So the name of this compound is 3-chlorobutanol. I can take one more example so you can understand. This time I'll just use this line structures. Okay, this one. I'll join here two substituents. So if substituents are there, you have to give numbers. So this is always carbon number 1, 2, 3, 4, 5, 6 and 7. There are two substituents. One is present at carbon number 3. So this is methyl and this is again methyl. So the substituents are what? Along with their local numbers. This is 3,4-dimethyl. So 3,4-dimethyl. Now parent alkane, since there are 7 carbon, so the parent alkane is heptane. Now as per the rule, you have to drop this E and add Al, so that becomes heptanol. Now to write its IUPAC name, what you are going to write here? So substituent first, so that is 3,4-dimethyl heptanol is a IUPAC name of this compound. So in this way you can provide nomenclature to the aldehydes.